Welcome to the AI in Manufacturing podcast here on Industry4.tv. I'm your host, Kudzai Manditereza, and today I'm joined by Zhitao Gao, who is the AI in Manufacturing expert based out of China. And today we're going to be discussing data-driven manufacturing with AI. Zhitao, welcome to the show. It's such a great pleasure to have you here.
Hello, Kudzai. It's my honor to be here.
Awesome stuff. So to kick things off here, could you kindly introduce yourself to the audience? Tell us more about yourself. Tell us more about your journey, and also about kind of like what are you currently, working on, and sort of like your company, what your company provides.
Okay, so my name is Zhitao, or you can call me also Steven. I got my degree in China and also in Germany. And also that was a time when Industrial 4.0 started. So I kind of was lucky to be there to see how Germany is becoming a country where Industry 3.0 started. And after that, I worked in short period in both in Germany and also in the US, and then I come back to China and work in one joint venture of automotive industry. And I started work in Tesla like 4 years ago, and now I'm working on my own projects. That is very exciting, and that is focused on data-driven manufacturing with AI, which is also topic of today.
Awesome stuff. So, I mean, as we just said here, really your focus is on data-driven manufacturing with AI. So kind of like, first of all, why to set the stage here for our audience, why do you believe it's important for manufacturers to adopt a data-driven approach? Um, uh, in other words, what are the challenges with traditional manufacturing that makes it critical for them to adapt to a data-driven approach with AI?
Mm-hmm. Yeah, actually, I used to work like long ago. That was 2016, around that time when I used to work as an intern in a manufacturing company, which was in South Carolina in the US. And I was doing some dashboarding and also some data analysis based on production data from the production lines, and used to do a lot of reports for our production line. And I've got to feel that everybody, when they're talking with the issue, when they are talking about a solution, they talk about their feelings, right? They tell, okay, here is a problem, and I feel that is reason, and I feel that is how I can solve that. And after I did blah, 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 and I see the yield is going up for some percentage. But when I look at the data, I see something different, right? Because what do you do is maybe one of the cause that production numbers goes up, but you actually cannot prove that. It's kind of like you cannot prove the correlation or is that causality just from your feeling. So after that, I did a lot of data analysis on the production lines and tried to find every root cause for every problem. And that is time where I realized data is very important for production line. But back to that time, I didn't realize the power. I think that is important, but I didn't see the power until there was 3 or 4 years ago when I started working Tesla's factory. When they launched the factory for producing battery and also the cars, the drive unit, and everything needed to build for a car. And we had a huge issue with yield. There was huge issues there. A lot of engineers, like more than 30, 40 engineers are working on that problem. We tried different ways to change the equipment, change the parameters, try to dig into the materials flows, and everything we try to improve the production yield. That works for some time, but still we see the huge variation from day to day. Like today you got 50%, tomorrow you got 70%, and you never know why. And that time when I dig into the data, I finally realized there is one reason. That is, some data comes from our supplier, and that data tells you why the yield varies from day to day, because the different supplier batch leads to the final yield is different. That is from something from our supplier, not from the factory, because everybody is looking to the factory, but actually the reason is out there. And also there are some cases which I see the temperature outside, like the temperature is low or temperature is high, and you got different yield because your process is very sensitive to every factors from the equipment, from the environment, that are all sensitive. And after you got data, and you can run algorithms to check through all these possibilities, like one by one. Just not because you don't have data, but because if you don't use data-driven approach, you just don't have that time, right? You have 100 issues to solve, and if you don't have data, you cannot know, okay, is this weather really related to the problem? Possibly, but there are a lot of possibilities out there. Only after you got this data, you can check them in a very short time. Then we will know, okay, maybe there is material, maybe there is temperature, and you will finally know the root cause for every problems. After these stories, I finally realized in modern manufacturing, there are too many issues to solve. But with human experience, you can solve maybe 70, 80% of them. But still, the most critical, maybe 10 or 20%, is hidden in the water. And you can only fight that from a data-driven perspective. That is the reason why I think data-driven manufacturing is definitely a big thing.
Awesome. Yeah, it really sounds to me like it's kind of like how you put it is really about, those hidden factors that are almost impossible to detect through human experience, or just you won't have enough time to dig through the data to get to, that reason or cause for these variations that you mentioned about. So, I mean, when you look at the manufacturing landscape, what kind of like, in your view, are the top opportunities that AI offers for data-driven approach to manufacturing?
Yeah. So we were talking about AI in manufacturing. If we look back in the history, and there is vision technology, computer vision, that brings a lot to manufacturing. Like from 10 years ago, when a lot of companies trying to apply a vision system to manufacturing, especially for defects analysis and for quality control, and also maybe for guiding the robots and so on, that already brings a lot to the manufacturing. And from maybe 10 years from now, we are Predictive or other like industrial IoT, Internet of Things came out and becomes more mature. And then we were mainly talking about predictive maintenance or like root cause analysis with data-driven methods and all these kind of data-driven things. And until last year, when ChatGPT or let's say transformer-based language model became a very mature thing, we finally realized that GenAI is going to bring a lot of evolutionary changes to our manufacturing. And why is that like evolutionary? Because one thing that we remember is we have such a huge like expectation for predictive maintenance, right? Because when we were talking about data, we say, okay, if you can detect every failure of the maintenance, the equipment, and you can know how to like better do maintenance on your production line, and the machine will never break, and you will have zero downtime. But in the end, you still have to maintain that, right? You still have to do the maintenance job, and you can't just escape that. So there's a lot of people say, okay, predictive maintenance is actually failed because we're expecting, like say, a production line which is running in 100% OEE without any break, but you cannot get there. But actually, from what we see now with GenAI, it really changed how people work, and not just to let you know, okay, here you gotta, maybe let's say if we compare that how doctors telling to their patient, it's like we have something to tell you, okay, you have a problem with your heart, you have a problem with your eye, but also the GenAI capability brings to us is some AI system in manufacturing will tell you not only what it sees, but also tells you why, and also tells you what you should do next. It's like it can look into your body, it can look in your data, it can scan your body and tells you, okay, because you have eye issue because you're too tired, or there is anything wrong with your lifestyle, Even it can give you some recommendation how to live, or it can give you some recipe, and you can live your better life. So I think from these three generations, like vision, predictive maintenance, like or the data-driven methods, and also GenAI, and GenAI will definitely wrap everything into a bigger system, and we will call it like a manufacturing expert with AI, or manufacturing AI system, which can cover a lot of applications to that, and that really works like a, let's say, Superman engineer, right? That's maybe really bringing some revolutionary change to our production.
Yeah, I mean that's quite an interesting, thought, and of view of the approach where you've got, predictive maintenance, which is basically based on predictive analytics, and kind of like what you're saying is that it may kind of like tell you this equipment is about to fail in 2 days, maybe the remaining useful life of that piece of equipment, but you still need to go back and fix it. Again, tomorrow it will tell you again, this equipment is about to break. But for you, the holy grail is kind of like kind of getting to the point of why is it breaking down, right? Kind of like
Yeah.
layering on top of predictive analytics, that reasoning capability to be able to tell you why is it breaking down, so that next time it doesn't break down, faster than expected, right? Is that kind of like how you view it?
Yeah, it's like so we were actually explaining or expecting something which is a superpower for manufacturers, right? It's not only just to show you some charts and tell you some result and with a model behind that, but really like, or it's also like if you are a shop lead, what you are expecting in your production lines, what you are expecting from your engineers is like, it can tell you what is happening, and it can tell you what should we do next and what is gap to 100% OEE. And also there must be some reasoning behind that, right? And if you don't know the reasoning, you can never tell if that works or not working. And to be honest, as we are an engineer, let's say maybe 70 to 90% of activities that we do for the production line is not useful at all, right? Because it's the every time you do experimentation, and most experimentation will fail. Let's imagine if every improvement for the production line is effective, and your production line will already be 100% OEE with some like very high speed or very high output. That is reason. So every time if there is problem, or it's like you failed in solving that problem, you need to learn from the knowledge, and that knowledge will give you a better production line after you really take the failure in and learn from that. And that is only like that kind of learning capability is not provided by the traditional like AI or typical like data-driven methods.
Awesome stuff. Awesome stuff. So, I mean, there are some manufacturers that realize this opportunity and also kind of like are on board with where this is all going as far as getting value out of AI and transitioning into data-driven manufacturing. But in my experience and kind of like in my interactions with some manufacturers, they still a huge chunk of them still struggle with adopting AI and implementing AI in a way. So what would you say are the biggest barriers that are preventing manufacturers from adopting these technologies?
Mm-hmm. Yeah, I think there are a lot of barriers. As we see the AI adoption or any new technology, its adoption in manufacturing is slow and hard in comparison with like consumer electronics, or in compare with any customer-facing industry. Manufacturing is always late for new technologies. I think there are multiple reasons, but one thing that is most important is definitely the people. It's how people see these things. Because normally you see manufacturing lines doesn't change once they build up their production line, right? It doesn't change. It just runs until it fails, like in 15, 20 years. But this time, what I see is AI is definitely bringing something new to these older production lines, whether you got a lot of sensors, you got SCADA, you got MES, or you got everything, you got a digitalized production line, or you got a typical production line. This time, GenAI will definitely change something, especially change how people work there. Because people in manufacturing tend to be very conservative, tend to be late adopters to this new technologies. Just like let's say when is the first time you use Face ID from your iPhone? I think that is already maybe 10 years around that.
Yeah.
And after everybody realized, okay, I can unlock my iPhone with my face, and I can feel there are a lot of vision applications around myself in the life. And after that, the massive adoption of computer vision in production lines is growing faster than before. And that is also, this time, I think GenAI is definitely going to kind of apply to manufacturers faster than before, because like ChatGPT and our GenAI application is like very well adopted by people in the life. So in the end, it's like people is managing the production line and how people think and how people feel about the production line. Like I ask myself, do I need something to change my production line? Does this maybe 75% of OE, should I improve that? And do I need to replace this operators with computer vision? Do I need to use predictive maintenance to prevent any machine downtime? I always ask myself these questions. So it's like if people are doing that very often, like asking themselves, do we need to use new technologies to make them more competitive in the market? And the speed of adoption of AI in manufacturing will be faster. So the summary is that as like people in manufacturing is definitely the key thing. And I think as long as our new technology in their life happen more, and you can see the power of this kind of new AI technology in their life, they will try also to adopt some of these technologies in their manufacturers. And that is the biggest barrier. And besides that, I think data, a lot of people talking about data, and also especially clean data, right? You get a lot of data that is not clean. And also people are talking about contextualizing data, because if you collect a lot of data from IoT sensor, you can now know its meaning, and also data management and data platform. And everything around that is also, I would say, that is only about cost, ROI. The technology with help of a lot of IoT platforms, which growing very fast in past decade, I don't see any problem with that already. So I think that problem is already like solved, as long as you got a very clean use case and you can know, okay, what kind of technology do we need to adopt? So the data issue is not an issue, and more important is people, how people work, how people think in their manufacturers. And that is biggest barrier to adopt more technology in manufacturing.
I mean, those are quite some interesting thoughts that I would like to, dig deep into a bit here. So first of all, the people problem. I want us to kind of like go into, because the framing of it is that it's more cultural, right? It's kind of like more of a cultural shift. Someone who's been working in a manufacturing environment for 15 years, and they've solved problems without data. For them to make that shift to then start to look at data to make those informed decisions, that's something that may not come naturally for them. So do you believe, or rather maybe as a solution, that it more has to do with skills development? Do you believe that kind of like plays a part in kind of like really, I mean, using your example for like a iPhone first camera, where you've got uh, the younger generation who are adept at understanding how these technologies work. They're always poking and changing things and and trying things out. But in the factory, you don't have that opportunity to really try things out and experiment. So you may not get as much information as often as you want to. So do you believe that is that could be corrected with more skills development, or what's your take on that?
Yeah, I think it's way that we like conquer this problem. Let's call it problem. If we see that, it's giving like more like training or more technology development for these people, and make these people see, okay, there is already a lot of examples that applies on this technology, and they can see much more than before. I think people in manufacturing is not like they're not different from other industries. Some people say people from industries from manufacturing is different. I don't say that, because they're just the people, and people tend to stay where they feel comfortable, right? Everybody likes, just like you and me, we're trying to stay wherever we feel comfortable. And manufacturing lies, if that is running stable, you feel very comfortable. And the only thing that makes you grow, makes you learn more, is like to push you into a situation that you don't feel comfortable. It's like to giving you more examples, and like always questioning your team or your people around you, like how should we improve? Should we use new technology? Because like everybody is doing improvement, right? But adopting new technology is definitely something new. So you kind of like always asking questions and always giving people more examples. And the observation that I mentioned about iPhone and cameras is like, if a technology is very wide adopted in the world, in your life, and you can also, you think about that more, because you see, okay, here is camera, and why should this camera can't detect the quality issue, because it's also a camera, right? So you think about that a lot. And also, if you use more ChatGPT or other application in your life, and you ask questions about them, like how should I fix the computer? And also in the factory, you ask them, how should I fix this motor, right? How should I fix this machine? And then you know, okay, this kind of technology can be very well applied into the manufacturing. And now also you see a lot of like personal assistant and this kind of similar technology, and you definitely see that more into manufacturing. And to be clear about this, how should we change people, is definitely putting people in a place where they are not feeling comfortable anymore, by showing them more examples and always asking them questions. And there is some better ways of doing that also. When I was like managing this team, I tried to set our systematic approach of this training. I do a lot of training courses, and I design a training courses for 3 to 6 months. And there is like 10 to 15 courses of the series, and I can teach people, and not only technical people, but also non-technical people from the production lines, and to let them feel how that works. Start from very basic algorithms, always to this computer vision applications. So after the entire training courses, you have better understanding of everything.
Awesome stuff. I mean, it's interesting that you kind of like mention, with your courses, that you kind of like have got this approach where you're providing courses for technical folks, and also you're kind of like providing courses for business leadership, and it's clearly a recognition that there's different stakeholders that need to be on board for this to work. So I kind of like, this maybe ties into my next question, that boils down to kind of like the strategy, right? To say, okay, so we're talking about this idea to say, you say, for example, the data platforms are already out there, once you've got the use case, and also putting people in those uncomfortable positions. But from a strategic perspective, what would you say to a manufacturing leader who's listening to this conversation right now? How should they look at this from a strategic perspective, as to how should they approach this?
Mm-hmm. I think for this kind of, let's say if you see this bigger strategy, there is always two approaches that I would take. One is bottom down, and one is like bottom up, and one is top down. So from top down level, it's like it's kind of more, you cannot like design some small applications. Maybe you are a factory leader, you manage maybe 100 engineers, and you manage maybe 10 factories with 100 production lines. You cannot just say, okay, let's put some applications right there. But rather than that, you should think systematically, and what is the thing which is needed for all the AI applications. So you will start from big platforms. You can say, okay, I need a data platform, which is providing the data management functionality, data collection, and everything. And also, you need a platform for your AI application. You need to kind of have a AI platform which providing the reasoning capability and all this basic functionality to put you into a place that everybody can utilize this platform to create their own, let's say, GenAI copilot, right? From a top-down level, you are providing capabilities, and also you are providing people the right direction. Like, okay, so now I'm going to say AI is coming, and everybody should learn that. And here is a platform that I'm providing to you, and everybody is going to adopt that. So, and also another approach is from, like, say, bottom up, right? For bottom up approach, it's like you are kind of need to encourage people to find their problems, Where do you see the opportunity to improve, and where do you see their problem? So it's like, do you have too much questions to answer? Do you have too many maintenance jobs to do? Is your project management too heavy? What is the thing that you feel painful in your life, right? And after you got two of these things, right? You got platform, you got platform and capability, and you got problem. And then people, engineers, they are automatically trying to combine this thing together. Okay, here I got my problem, and here is platform, and that is way how people start to think about their own applications. And that is, I think, manufacturing leaders should do in manufacturing. Let's say you're running a big organization.
Yeah. So I'd like to probe into that a bit, and maybe kind of like tie it back to the issue of data that we spoke about earlier. So I mean, kind of like how you framed it is that you've got this bottom up approach where you've got factory users who need to kind of like identify all these problems that they have and they may want to solve, right? And in some cases there's a situation whereby you're a plant manager, you come up with a problem that you're facing, and then because you don't have maybe the tooling to be able to kind of like get the data that you need, in most cases you're always dealing with the centralized data team, where you kind of like say, I've got this problem where machines are breaking down and I need to fix that to be able to kind of like keep up with the production requirements. And in many cases the central data science team is the one that then says, okay, we've got, where is the data? They go into a data lake where all of this data maybe have been stored, but in most cases that data doesn't have like the context, like a data scientist doesn't know kind of like what is important to understand about a compressor and things like that. I know, so there's kind of like that gap with the domain expertise. So I kind of like want to sort of like get your sense on how that data management should be approached. Sure, we've got the IoT platforms that allow you to get the data and stuff like that, but we've got this bridge between domain expertise and actual data scientists that perform, generate the insights for the end user. How do you see that should be approached for it to be more effective?
Yeah, I mean, like, understanding of data and also use this data and also apply some advanced analytics or advanced algorithms to this data is definitely a long process, right? Start from collecting always to giving the result. And what I see this problem is like typical organization is trying to solve this problem by identifying who is going to do what, right? So like maybe end users should provide a list of data collecting points and also the meaning with that. And that will have a package and give that to another people, which is let's say automation engineer. So they are going to be responsible for collecting all this data from SCADA, from IoT system, and then they should provide this ball, pass this ball to data scientists, and they are to apply modeling technology and maybe give that to another product manager to ramp everything together into a product, right? That is how normal people is doing that. But what we see is definitely at this time, one people like that one person
Yep.
should definitely have every knowledge, like all the knowledge here to do this job in order to like have a very smooth process. And that is also doable. So we were actually training a lot of these engineers, especially like you are engineering factory process engineers, equipment engineers, like all these engineers. And these people here, they are very eager to learn, and they have very good background, whether in a college or wherever they came from. Nowadays, people do know a lot about database, computer, SQL queries, Python, and everything. And also, that gives already the fundamental knowledge, understanding what data is, right? Data is not the thing that shows on paper, but like maybe in Excel sheets or in a database. And after we train them with how and what data science is working, and also how software engineers is doing, these people is capable of doing the entire workflow by themselves. And one thing you only provide is very simple platform. You don't have to like provide them a very complete like no code platform, which is you can drag a lot of elements there and there is a pipeline. You really don't have to have that. But yeah, it's good to have that. Some of it is good, but more important is like you provide the training and the knowledge to them, and also make them understand that technology is something that you should learn, and that is not hard, right? Because a lot of engineers say, okay, I can't do the modeling. I know the machine, but I can't do the modeling. But after you show them, the modeling is so easy, right? And especially from this GenAI stuff, you can easily apply knowledge. You can just talk to them like, I need a model to modeling the vibration signal of this machine to see if there is any anomaly in the vibration. And it tells you what kind of anomaly detection algorithm you should apply at first. And that gives you a feeling, okay, there is something that I can do that. And we did that for a lot of times. We trained more than more than 200 engineers to be capable of applying all this entire process of collecting data to modeling. So I think that is way that we understand here, because data contextualization, understanding of data, and understanding the pipeline, understanding the algorithm is definitely very hard. And if you are trying to do that with an organizational perspective, it's like there is one guy doing that, one guy is doing that, one guy is that. You'll be super slow, and that will be super slow.
Yeah.
And if somebody change their job, I would say change their role in their organization, and the chain will break again, right? Because you are kind of saying, because this job requires 4 kinds of capability, and you need 4 people doing that. And if one people is working slow, and you need a lot of tons of like time for communication. So what I see the problem is definitely we need a good platform. I don't have any to recommend for now. We need a good platform for data management, and also management of this contextualization, and also data modeling. But the more important is like one engineer should know everything about this problem. And this kind of process can be managed in one platform. And that is how you success. That is how big organization becomes very successful in adopting AI and adopting all this technology fast in an organization.
That is super interesting, and I'll kind of like want to sort of like linger on that a bit, because it I mean, ideally this is kind of like really what needs to happen, right? And kind of like this is how full stack software engineers came to be, to be able to understand all aspects of the stack. And it kind of like seems to me that this is a requirement for a new kind of engineer to be trained up, because the reality, I'm not sure what the reality is like in the Chinese environment, but in kind of like in Europe and North America and in Africa as well, it's almost always the case that the automation engineers, they really don't know a lot of course, nowadays almost everyone understands a bit about IT because of all the smartphones and laptops and things like that. But they don't quite understand a lot about all the IT SQL queries, and it's another world, right? Sure, people can be trained, right? But the reality is that a huge chunk of people in the OT don't understand IT. A huge chunk of people in the IT don't understand OT. Some of them, they've never come across a compressor. They don't know what it looks like. So the reality as it stands right now is that there's that divide. And if I understand correctly for you, you're saying, again, to say the solution to move faster is to make sure you train up this new breed of engineers that is capable of understanding across the spectrum. Is my understanding correct?
Yeah, exactly. I think I already see the trend. Like, people used to only do a small part of that in a factory, and nowadays you already have that kind of feeling, or you already observed that maybe an equipment engineer is also got a very good understanding of how the process and how the planning, and also what I feel in the future, because we don't have that much engineer, right? Because kind of the population is going down, and labor cost is very high, and also because of that, because knowledge here is like it's very easily to be accessed from the internet and from everywhere, right? It's knowledge required to be a process engineer, or to become an equipment engineer, or become a software developer. And you can access that everywhere. And also, I think people here, the learning capability of people nowadays is stronger than before. And so I already see a lot of young engineers is able to do like maybe 2-3 different kinds of jobs just after 3 years graduation from their college. They're already able to do almost everything in the factory. And I do see the growth rate of this kind of engineer. If you see, okay, this kind of engineer, the growth rate is super high. And I see in the future, let's say the platforms, let's say at the beginning, if you are using TIA portal or some other programming platforms for PLCs or for the SCADA system, and there is not so much capability inside of this platform. So your capability is also limited, right? If you know the algorithms, you have to jump out from the automation solutions to this IT solutions to do that. But we recently observed a lot of things is kind of going together. It's kind of fusion, right? Like platform from Backoff, you can do PLC programming on that, and you can also write algorithms in that. And also, just like computers, right? And also the protocols, like 10 years before, you got a lot of protocols. Now you can only see maybe OPC, MQTT. You can only see a few of them.
Yeah.
So the fusion of technology and the fusion of everything is becoming a trend. And also, what we see here, the multimodal models. Like before that, if you're working in a factory, you need one model to detect if there is anything wrong with the motor, and if you need another model to detect if there's anything wrong with the bearing. Like every small part of the machine, if you want to do very clean diagnostics of what is happening on the machine, you need to have a very small model, right? But nowadays, after ChatGPT, you can see the large models, the foundation models becoming big. The foundation models can not only generate text, but also generates videos, and also generates images, and also even sounds and video. And I think that will also happen very soon in manufacturing world. It's like the models is becoming more powerful. It can manage everything. And the platforms to host the model is becoming also powerful naturally, right? You can also program everything. You can program in PLCs, you can program the machines, you can program the models in one single platform. And the user of this platform is not automation engineer, not process engineer, not equipment engineer. It's just engineer, right? You can do everything with this platform. And you become the that kind of engineer to know everything. And let's say the shop leader is going to say, okay, you own the production line by yourself, and you can just do everything for this production line. And also with humanoid robots and everything, like you are able to run production line with very limited resources of engineer, but a lot more algorithms, a lot more models, a lot more humanoid robots. And that is how I see the future of manufacturing.
100%. That's fascinating. So, I mean, you have want to kind of like talk more about really your service offerings and kind of like your solutions specifically that you help the industry with. So you've already kind of like spoken about how you into the education side of things with creating training material. Maybe you can explain a bit more about that for us. What kind of like service offering you offer in that regard, and also talk about your AI in manufacturing service offering.
Cool. Yeah, so there are kind of two parts. So first is we are kind of building a product. We will call that like a co-pilot for manufacturers. And that is something similar to what I described earlier. It's like that is a kind of co-pilot helping to understand your current situation, to help you to read your docs and learn from the documentation, and also to understand your problem and give you advice what you can do next. Let's say you have a yield issue, and I can tell you how to improve that. If you have a maintenance issue, I can help you with how to build your production line better and also have a lower cost of the maintenance. That is kind of the kind of engineer, but we are going to build that with AI. And another part is like we are running a community of manufacturing AI, and that by that community we are kind of a bunch of people who is like practitioner in this area. We are building solutions, we are building products, and some of them are also as managers of this production lines. And with this community, we are talking and sharing a lot of activities and to learn from each other. And also we create some like say consulting services and also training materials based on this community. Yeah.
Awesome stuff. So, I mean, to kind of like really bring all this together. So, first of all, I wanted to get your sense on what do you have some real world examples or use cases that you could share with our audience?
Yeah, we recently was creating something like we are for this for equipment managers. So there is kind of talk to machine functionality. So imagine there's a machine out there, and you feel there is something wrong with the machine. Either it's yield, or either it's like OEE or whatever. You can just talk to this machine, and you can ask questions to the machine. What's wrong with you? Yeah. And it's like, is there anything wrong with this with any components in your body? And that machine will respond, right? Because that machine is already trained with its own documentation, and it also connects to IoT services. It's like you have a one-to-one measure. It's not like really digital twin, which is you see what is fancy, but rather than an AI, which is just kind of yourself. It's kind of like the services provided by some people like the character AI or something. But that AI is pretending to be your equipment, not really like people. And with that kind of AI, and you can imagine you are facing a equipment, and that is smart, intelligent, talks to you and answer your questions about how can you improve that. So with that kind of AI, you are able to see everything happen on the production line and see that equipment. And also the equipment, they are talking to each other, right? So here one equipment may say, okay, I got a problem, and I cannot produce as much as possible. And there are parallel stations, and they can also take over some of the jobs that equipment is doing. And also after kind of they learn a lot of things about themselves, and they can run some self-diagnostics, right? So today I'm doing very well. I'm running 100% OEE, and tomorrow I'm only doing 60%, and I can do some self-diagnostics about myself. Is there anything wrong with myself? Like imagine the Jarvis or something like self-diagnostics running, and I give a report, and somebody please help me with this maintenance. That is something that we may imagine, which is very good use case for like almost all manufacturing industries with heavy machines.
Awesome. I mean, the kind of picture that you sort of like paint as a sort of like idealistic, way of running operations is something that in today's world also may face some resistance as far as the loss of employment is concerned, right? Kind of like you spoke about this idea of having one engineer owning the entire line. You've got this idea of, machines talking to each other and self-adapting, self-optimization that effectively cuts out a lot of, obviously it kind of like really makes the company more competitive and really, but it cuts out, like some of the labor force. And this is kind of like, I think an important point of discussion for in many countries, really, to say how do we balance that. What's your thoughts on kind of like the loss of employment due to mass automation?
Yeah. So actually, I'm not an expert of solving like society problems, right? Like unemployment, you can see with kind of economic growth is slowing down, or like crisis. A lot of things is happening. But in general, I think manufacturing is now growing faster than people think, and also that is going to grow faster than before. With a lot of kinds of reasons, manufacturing in almost all regions is growing now, right? A lot of regions, they need to keep their own supply chain safety, also to like building their own fundamental like foundation for the economy. So manufacturer industry is growing in a lot of regions, and especially in US or in other big regions, the growth rate is way faster than before. And now comes to a question that exactly you don't have that much engineer available on the market. There is no engineering shortage. There is no unemployment. There is just shop leaders. They don't have enough labor. They don't have enough engineers, right? So actually, I don't have any concerns about like one engineer is managing the entire line, so the rest of them is going to lose their job, like something about that. It's just like, if you can imagine, like you can build a car with 50% of the cost. You can build like if I can get a car with 15% of the price, I may get another 2-3 cars, right? If you can get let's say an iPhone with 50% of your price, you may buy another iPhone recently. If you can get a boat in 50% of the price, and you can get more boat, and that requires more factories. So like there is a cycle, right?
Yeah.
Higher efficiency, like more consumer goods and more factories and more engineers needed. And also the cycle is going to run smoothly if, let's say, you are really bringing some good technology to release the productivity of engineers.
100%.
Not like putting more extra cost on that.
Yeah.
And this cycle will continue.
Yeah, I mean, sorry to interrupt there. So I kind of like want to sort of like push back a bit on So I guess for engineers, 100%, there's huge shortage of skilled labor, highly skilled labor, for that matter. But kind of like when I'm sort of like talking about employment, I'm kind of like talking about the like non-skilled like workforce. Someone who's just packing things and putting them there. Someone who can be easily replaced by a robot, right? Like literally just replaced by a robot. So for engineers, 100% agree with you. But there's a huge, which is actually the majority, right? The people working the shop floor, kind of like performing all of these regular checks, and moving and packing things. And the reason that I bring that up is, so there's the broader societal impact of it that obviously you're not expecting, and you're not able to sort of like, control. But there's that, I think you spoke about the idea of people change management. As a manufacturing leader, once you start to introduce these systems, obviously you retrench staff. There's going to be lots of motivation to say, oh, so and so has been removed, so I'm next, right? I'm not a skilled person, so right now they're mostly figuring out how to replace me, and so on and so on and so forth. So there's that, change management. How should manufacturing leaders, of course, for shareholders and for the company, it works really well to really optimize as much as possible. But the leaders, or the ones who have to make the decisions and kind of like have to manage those people directly on a day-to-day basis while you still go through that change. What's your advice, and how that should be, approached?
Yeah, actually, I am not really good about this point, like managing these people and also managing like after maybe a massive automation on our production lines and hundred of employees, hundred of normal like blue collared workforce need to leave this company. I think that is a big thing for this entire society, just not only for manufacturers, just like maybe what you see on Amazon, and also what you see for other industries. If there is automation and if there is replacement of this labor, and that happens every time. So what I see from this problem is like, say, you should not say no to all these big changes. And every time a technical revolutionary stuff coming out, and it changes something for this entire society, change how people live, change how people work, and there must be a small part of this, maybe some jobs just vanished, right? It just disappear in this entire society. I still remember a very good example that at the beginning, you have some professional people which is just responsible for typing your words into the computer, right? You don't have a computer at the beginning, or only a few people knows how to operate on computers. So it's like always like you should have somebody to help you to type some words into a computer, into a printer, right? And these people just disappear after everybody knows how to operate on a computer. And actually, it didn't say anything, right? It just you say, okay, I got a new laptop, I got a new technology, and everybody is happy, and the entire society is going to grow. And I think those people there, which is doing the old job, it's just a part of the society, and everything should move on. And also, I don't think that should be some crisis for this entire society. If the process happened too fast, there might be some problems, right?
Yep.
Like, sudden, like a lot of people lose their jobs. There might be some problems, but I think it's like the fusion of this technology is happening with this speed, right? So it's growing slowly down and accelerate and deaccelerate. Yeah, so what I see here is I think it will happen, and everybody should be prepared. Either it's a shop floor manager, or it's the director, or it's VP of the entire company, or it's just you and me. We should be prepared. Nothing else.
100%. I think this is kind of like a nice segue to talk about our last, point for the day, really. So I want to get your take on, where do you see all of this going? What is the future of AI in manufacturing, say, in the next 3 years? What kind of picture do you see, manufacturing, AI impacting manufacturing? And what's your advice for shop floor managers, VPs, as you mentioned, into how to best prepare themselves for this future of AI in manufacturing?
Yeah, I think let's say if we see 3 years, I'm not expecting a huge change in just 3 years. People say there is coming, AI is coming, a lot of things coming very fast, but I think, let's say from 8 to 10 years, there will be huge change to the manufacturing, especially how knowledge workers in manufacturing, like skilled labor, also engineers, and these people will heavily rely on AI, like AI for knowledge management, AI for information collection, AI for generating ideas, and AI for solving problems. And they will heavily rely on AI to plan everything and to know everything, to manage everything. And till then, maybe the biggest asset of a manufacturing company is the knowledge and also the AI models based on that knowledge. And because that is the one thing which is running the entire production line, and also maybe it manages like hundreds of humanoid robots to run this company, and like one big brain knows everything, and there is also robots running this company. But in short term, let's say 3 to 5 years, and it's still growing, right? It's still growing, it's now at and the growth rate is also growing. So what we see in 3 years and how can we be better prepared is also to keep a big eye open, and also let's say to try this technology as soon as possible. So you should definitely try. And if that is not mature, you should try again. If that's not mature, you should try again. But you should definitely believe that something will happen very soon. And if one manufacturer is very successfully adopting new technology in improving efficiency, you will be very competitive in the market, because we all know that the margin of this manufacturing industry is completely, let's say, is very low, or normally it's lower than, let's say, 10% or 8%. And if there is AI happening to be a little bit more competitive in comparison with others in the same industry, there is a huge advantage. And also with the cumulative effectiveness of this AI, like because it learns a little bit more than others, and also gives you, let's say, maybe 2-3 years advantage in comparison with others. So nowadays, I would say we already see the change. We see the trend. We see how AI is changing a lot of things, changing the how we see the videos, changing how we write articles, changing how everything's here. And the manufacturers, they should expect the same change happen there. And also this time will be faster than the speed that we adopt computer vision in their factory. Like from beginning to now, for computer vision, there is already 10, 12 years. And we already see a lot of computer vision application in the factory. But for GenAI, I would say that will be maybe 50 of the time. In 6 to 7 years, there will be already a lot of applications there. And that will also blow your mind.
Wonderful. So thank you so much, Zhitao. So we're basically going to provide links to all the online platforms where you could be found. And also as soon as your product is out, also we'll be able to also link it to the description of this video. So again, thank you so much for taking the time to join me today. If you've got any last words for our audience, please feel free to share with them.
Yeah, it's my honor to be here. And I think manufacturing industry is kind of conservative. A lot of people is not very not willing to share a lot of knowledge. So I think the podcast of Kudzai is definitely helping a lot of people to know what is happening out there. I encourage everybody here to watch all the video from Kudzai and learn a lot more. And yeah, keep in touch. And thanks for everybody.
Awesome. Thank you.
Thanks.